Have you ever wondered if the very first stars born in the universe are still out there? Did they all die out? And what generation does our sun belong to? The number of stars in the cosmos is absolutely mind-boggling. Even our own Milky Way has around 2,000 billion stars. So astronomers started observing and studying the first generation of stars, and what they found totally blew everyone's minds. The birth and evolution of these first stars turned out to be completely different from what anyone expected. So how do scientists actually classify stars? And are the very first, most ancient stars still around somewhere? In this video, we are diving into the history of stellar observation, and whether researchers have ever detected those original stars from the dawn of the universe. When you look up at a clear night sky, all those glittering stars look like gems scattered across a dark canvas, forming all kinds of constellations. Back in the day, people had no idea these shining points of light were actually stars, just like our sun, radiating heat and light. It wasn't until 1610 when Galileo built the first astronomical telescope that humanity's understanding of the cosmos truly changed. Then in 1780, astronomer William Herschel started measuring the number and motion of stars and was the first to suggest that all those stars we see are suns just like ours. He even drew the first map of the Milky Way's structure. But how old are these stars? How long do they live? Those questions really puzzled astronomers for a long time. Fast forward to the 1860s, when Italian astronomer Angelo Secchi started classifying stars based on spectroscopy. He noticed that stars with similar colors had similar spectra. Cooler stars tended to be red, while hotter ones leaned blue. Then in the early 20th century, female astronomers at the Harvard Observatory studied thousands of photographic plates containing stellar spectra. They categorized stars based on surface temperature into 7 major types: O, B, A, F, G, K, and M. Our sun falls under class G, which are yellow dwarfs. But get this, red dwarfs, also known as M-type stars, make up about 75% of all stars in the Milky Way, while yellow dwarfs like the sun only account for around 7%. In the 1940s, German astronomer Walter Baade made another huge discovery while observing stars. He realized that some stars in our galaxy were only a few million years old, while others were over 10 billion years old. So which of these were the first generation of stars? Which came next? And could there still be first-gen stars lurking in the deep universe? That got scientists searching for them. In 2022, a team of astronomers from Johns Hopkins University made a surprising discovery. In Hubble telescope images, they spotted a very unusual star in a distant galaxy, and named it Earendel. This star was born less than a billion years after the Big Bang. Since the universe is about 13.8 billion years old, that makes Earendel around 12.8 billion years old, potentially one of the first stars ever. It had at least 50 times the mass of the sun and a surface temperature of about 20,000 degrees Celsius, but later studies suggested it was more likely a second-generation star, not first-gen. So how do you tell what generation a star is? It all comes down to its chemical makeup and formation history. First-generation stars are made almost entirely of hydrogen and helium. They formed about 100 to 200 million years after the Big Bang and were enormous, dozens to hundreds of times more massive than the sun. Because of that, they burned bright and fast, living only a few million to a few tens of millions of years before going out in a supernova explosion. When they died, they sprayed heavy elements like carbon, oxygen, and silicon into space, which became building blocks for the next generation of stars. So honestly, the chances of finding a first-generation star still shining today are super slim. Here's something wild: in space, the more massive a star is, the shorter its life. That seems counterintuitive, right? You'd think more mass means more hydrogen fuel, but it also means stronger gravity, higher pressure, and way faster nuclear fusion. So these giant stars burn through their fuel crazy fast and end their lives in a supernova within just 10 million years. When they explode, they spread newly formed heavy elements into surrounding gas clouds. Once that gas cools down, new stars form from it. Stars are born, die, and are reborn over and over. With each generation, there are more heavy elements, and newer stars have higher proportions of them. You could say second-generation stars are made from the remains of the first generation, only with a richer mix of elements, though still mostly hydrogen and helium. So what about our sun? After studying it, astronomers found the sun has pretty high metallicity, meaning it contains a bunch of heavy elements that formed through multiple cycles of stellar evolution, fusion, and supernovae. By analyzing its spectrum and elemental abundance, modern astronomy classifies the sun as a third-generation star. That means it formed from debris left behind by 2 earlier generations of stars, so it's got an even wider variety of elements. Scientists have detected 6 to 9 elements in the Sun so far. You can think of first-generation stars as made of pure, simple gas. If we trace things all the way back, the Sun and every other star share a common origin. They were born from a primitive universe, filled mostly with hydrogen and helium, with just tiny amounts of lithium and beryllium. So where are those original third population stars now? A while back, astronomers found a star called HD 140283 that formed not long after the Big Bang. At around 13.6 billion years old, it's one of the oldest stars ever found. But because it contains some heavier elements, it's considered a second-generation star, not first-gen. So does that mean there are no first-generation stars left? According to stellar evolution theory, it's extremely unlikely, but not totally impossible. On June 7, 2023, a research paper published in the journal Nature reported a major discovery. An international team led by Professor Zhao Gang from the National Astronomical Observatory of China used data from the Lamos spectroscopic survey and found an ultra-metal-poor star named Lamos J1010+2358. Its chemical abundance closely matches theoretical models of pair instability supernovae from stars 260 times the mass of the Sun. This is the first observational evidence that supermassive first-generation stars actually existed, and it totally changes how we think about how massive those early stars could be. This discovery shows how pair instability supernovae contributed to chemical enrichment in the early universe. It's a big deal for understanding the origin of elements, early star formation, and galactic chemical evolution. Next, scientists plan to use the James Webb Space Telescope and other advanced instruments to take a closer look at candidate galaxies. They hope to collect high-resolution spectral data to pin down the chemical composition, temperature, mass, and other key details of stars in those systems, and maybe finally confirm the existence of those elusive first-generation stars, also known as population 3 stars. For us humans, the universe is full of endless mysteries. Every exploration is like opening a new door that shows us a broader and more amazing reality. I hope what you learned about stars today gives you a deeper understanding and sparks even more curiosity about the night sky next time you look up at the stars. Maybe you'll remember some of these secrets hidden deep in the cosmos, and maybe you'll feel a little more grateful for each day we have on this beautiful planet. Make sure to hit that subscribe button, give this video a thumbs up, and share it with your friends and family. Thanks a bunch.